Your Raga's faithfulness score is 0.91. That's solid, but it still means 1 in every 11 answers includes a claim unsupported by the context. In a customer-facing product, that's 1 in 11 users receiving confidently wrong information. But if we use hallucination detection, it adds a verification layer to catch those bad answers before they reach users. Here is what a hallucination looks like in practice. The context says returns are accepted within 30 days. The user asks if they can return after 60 days. The model produces the answer, yes, returns are accepted up to 60 days. That claim is completely absent from the context. The model filled a gap with a plausible sounding number. RAGAS catches this in batch evaluation. Hallucination detection catches it in real time before the answer is returned to the user. Natural language inference, or NLI, is the task of determining whether one piece of text logically follows from another. Given a premise and a hypothesis, an NLI model classifies the relationship as entailment, contradiction, or neutral. We use this for hallucination detection by treating each retrieved context chunk as the premise and each sentence of the model answer as the hypothesis. If a sentence in the answer is not entailed by any chunk, it is a potential hallucination. We load the NLI model using sentence transformers. The model Tiberta v3 is trained specifically for natural language inference and is fast enough to run in a production pipeline. We call predict with a list of premise and hypothesis pairs. The output is 3 scores for contradiction, entailment, and neutral. For our 30-day versus 60-day example, the contradiction score will be very high because the hypothesis directly conflicts with the premise. The hallucination checker works at the sentence level. We split the model answer into individual sentences using the NLTK sentence tokenizer. We extract the text from each retrieved context document. Then for each answer sentence, we will check whether any context chunk entails it. If no chunk entails a sentence, that sentence is flagged as a potential hallucination. We build this in 2 parts to keep each scene under 15 lines. For each answer sentence, we pair it with every context chunk and run the NLI model on all pairs in one batch. We take the maximum entailment score across all chunks. If even one context chunk entails the sentence, we consider it grounded. If the maximum entailment score stays below 0.5, we flag the sentence as a hallucination. The function returns a Boolean and the list of flagged sentences so the caller can decide how to handle them. Self-check prompting is a much simpler approach that uses the language model itself as the verifier. We send the context and the answer back to the model with a single question. Is every claim in the answer supported by the context? We ask it to reply with only yes or no. This adds 1 extra language model call per query, but requires no additional models or libraries. It is less precise than NLI, but fast to implement and good enough for many use cases. Here is the full production guard. We run retrieval and generation exactly as before. Then we pass the answer and context through the self-check. If the check returns false, we do not return the answer to the user. Instead, we return a safe fallback message asking them to check the source directly. This is a hard gate. The user never sees an answer the system could not verify. That one change removes the most damaging failure mode from a production RAG system. Self-check prompting is the fastest path to a working guard. It adds 1 language model call but requires no new models or infrastructure. The NLI approach is more precise and has no ongoing API cost per query, but requires a model download and slightly more code. For many teams, the right answer is to start with self-check and switch to NLI once volume makes API cost significant. Always log every rejected answer because they tell you exactly where your retrieval is still missing relevant chunks. You now have 2 tools to catch hallucinations in real time: self-check prompting for a fast, lightweight guard and NLI-based sentence verification for high-precision detection. Both slot directly into the pipeline we have been building across this series. In the next episode, we tackle semantic caching, how to store and reuse answers to semantically similar questions so your system gets faster and cheaper as it handles more traffic. Subscribe so you do not miss it. See you in the next one.